This is number 2 from the 2013 FRQ. So the problem is that a particle moves along a straight line for t is greater than or equal to 0 and less than and equal to 5. The velocity of the particle is given by v of t equals this function here. And the position of the particle is given by s of t, and it is known that s of t of 0 equals 10. So part A is to find all the values of t on the interval of t is between 2 and 4, for which the speed of the particle is 2. Now we know that speed is the absolute value of v, of velocity, and this is because speed is a positive value. So the speed in this problem is 2, which is given here. And since this is the absolute value of the velocity can be plus or minus 2. Remember that velocity can be negative when the object moves backwards. So this here is a quick sketch of the graph from my graphing calculator, and basically what I did to find the values of t, we plotted the velocity function from up here and y equals plus or minus 2, and where the points of intersection were between the interval 2 and 4. So when you do this, you get the two values t equals 3.128 and t equals 3.473. And this is where the values of t are on the interval 2 to 4 when the speed of the particle is 2. Part B is write an expression involving an integral that gives the position s of t. It says use this expression to find the position of the particle at time t equals 5. So since we're finding the position at t equals 5, the integral we set up is from 0 to 5. So we have s equals the integral from 0 to 5 of v of t, and plugging in the velocity function, we get -2 plus t squared plus 3t to the 6/5 minus t cubed dt. So this integral that I just wrote gives us the total change of position from 0 to 5. It's the amount of displacement from the initial position, and the initial position is s of 0 equals 10, which we get from the problem. So therefore s of 5 equals s of 0 plus the integral from 0 to 5 of the velocity function. And we can plug this into our calculators to find the position at t equals 5 is 9.207. C says find all times t in the interval when t is in between 0 and 5 at which the particle changes directions, then justify your answer. So if the particle changes direction, we know the velocity changes from either positive to negative or negative to positive. So by the intermediate value theorem, the particle must go through 0. So where is the velocity equal to 0? Looking at the graph on our calculators that I graphed, the velocity functions pass through the line y equals 0 between x equals 0 and 5 at t equals 0.536 and t equals 3.318. And we need to justify our answer. So this sketch of the graph shows t going from negative to positive at t equals 0.536 and goes from positive to negative at 3.318. So that's why the particle changes directions at these spots. Part D says, is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. So to find if the particle is increasing or decreasing at t equals 4, we need to compare the signs of the velocity and acceleration. If their signs are the same, the speed increases, and if they're different, the speed is decreasing. So v of 4 equals -11.476, and you get this from the calculator. You can graph the velocity function from the original problem and then go to second calc value and then plug in x equals 4 to find this y value. So then to get the acceleration, we take the derivative of the velocity, and you can also do this on the TI-84 calculator by pressing math and deriv and then typing in the velocity function from the original problem at x equals 4. So we end up getting that the acceleration at 4 is -22.296. So therefore the speed is increasing, and this is because the signs are the same. They're both negative.
So the problem today is an equation of the tangent line to the graph of y equals cosine of 2x at x equals pi over 4 is. And these are your 5 options because it's multiple choice. So First, looking at this problem, we need to find the derivative of the original function because it's finding for the line tangent to the graph, which means you have to find the slope of that line in order to find a line itself. So the derivative would be y prime equals -2 sine of 2x. This is because of chain rule. So now, to find the slope at pi over 4, we plug in pi over 4 into this. So y prime of pi over 4 is just -2, because sine of pi over 4 times 2 is sine of pi over 2, and that is just 1. So now to find the equation, we need to plug into point slope form. And to find point slope form, we first need to find a point, and because we have pi over 4 as our x value, we should find the y value for this. So plugging pi over 4 into y equals cosine 2x would give us cosine of pi over 2, which is just 0. So plugging into point slope form, we get y minus 0 equals -2, because that's our slope, times x minus pi over 4, because that is our x value. So the original function has to be y equals -2 times x minus pi over 4. And this is option number E, or letter E. The problem is the graph of the derivative of f is shown in the figure below. Which of the following could be the graph of f? So here's our f prime graph. So as you can see, at -2 and 2, the slope is 0, so we need to look for graphs that have a slope of 0 at -2 and 2. This means we cannot look to A, B, or C because they do not have a slope of 0 at -2 and 2. This means the only available options are D and E. So looking at the rest of the graph, we can see that it's negative from -infinity to -2 and negative from 2 to infinity. So this means that it has to approach -2 from below, and it has to be negative from approaching to -2, and it has to be negative leaving 2. So this means that D does not work because it's positive approaching -2 and positive leaving 2, which means that the answer has to be E because the slope is negative going to -2, and it's negative coming down from 2. This means your option has to be E because it meets all the conditions given by the f prime graph. The problem today is at what point on the graph of y equals 1/2 x squared is the tangent line parallel to the line 2x minus 4y equals 3. So again, we're looking at a tangent line, which means we need to find the derivative of the original function, which is y equals 1/2 x squared. So the derivative is y prime equals x because of the power rule. So with this derivative, now we have to set this into slope-intercept form. So we would have -4y equals 3 minus 2x, because you're subtracting 2x to the other side. You divide by -4, so y equals 1/2 x minus 3/4. So this means that the slope of this line is 1/2, which means that the derivative has to be 1/2, which means x has to be 1/2. So this means x equals 1/2. So immediately you cannot look to C, D, or E because x is not 1/2, which means the only options are A and B. So this is why you must get the same slopes. So now to find the y value, you plug in 1/2 into this function. So you have y of 1/2 equals 1/2 times 1/2 squared, which is just 1/2 times 1/4, which is just 1/8. So this means that it's B because your x is 1/2 and your y is 1/8.